Have you ever looked at a robot and wondered how does it actually work? What makes it move and what tells it when to stop and when to start? Is it just some wires and motors together, or is there something smarter going on behind the scene? Here's the thing. Robots may look complex, but the ideas behind them is something simple. Even something as basic as blinking LED can help you understand how robots work, follow the instruction, make decisions and interact with the world. So let's explore something interesting. We already did how to turn on the light and off the light using LED, but here we are going to learn how to control LED using code.
Learn tinkering.
If robots move and react, what's actually doing the thinking? Just like your brain takes the information, what you see, what you hear, what you touch, and decide how to respond. A robot has something simple. We call it the robot's brain. It's a really small computer like a microprocessor or a microcontroller. It listens to the sensor, maybe a button press, a sound, or even a light, and then it sends the instruction to the motors or LEDs. Input comes in, the brain processes it, and output goes out. Sound familiar, right? It's a lot like how your bodies work. And the cool part is we can program the brain line by line so the robot knows what actually need to do. Now that we know that robots need a brain, what does it actually looks like? It's not a big like a human brain, but in fact, most robot brains are small circuit called microcontroller. These little boards are what let us control light, motor, sensor, and basically everything a robot can do. You can see some microcontrollers here like Arduino Uno, Arduino Nano, Raspberry Pi, Microbit, and they are very simple, affordable, and powerful enough to run a full robot. And the best part, we get to program them so the robot does exactly what we want. Alright, we have learned that every robot needs a brain. Now let me introduce you to the one we will be using, Arduino Nano. This tiny board is even smaller than your palm, but it is a full of microcontroller, which means it's a small computer made to control things like lights, sensors, fans, and motors, and many electronic devices. And here how it works. We write instructions called code on a computer. Then we connect the nano using USB wire, and it follows the code exactly as we tell it. And that's how we bring our robot ideas to life. But why we use nano? Because it's simple, compact, and it's fit perfectly on small breadboards. Even though it's small, it has everything we need. Input pins, output pins, power connection, and brain chip right in the center of the nano. Now that you have met Arduino Nano, let's look how it's built. It may be small, but it has everything we need to control our robot projects. So let's start from the top. On the both side of the nano, you will see lots of metal tiny legs. These are called pins. Some of them are digital, some of them are analog, and some give power to the electronic devices. So the digital pins are used to send or receive signal, like turning on and off the light or reading if a button was pressed. So you will see them labeled as D2, D3, D4 and so on. Then there are analog pins, usually marked A0 to A7. These are used to read values from special sensors like light sensor that tells you how bright it is, not just on and off. And you also find power pins including 5V, 3.3V. These 5V and 3.3V are positive and GND is negative. These are like a nano's battery outlet. When you want to power something like LED or motor or sensor, or you want to connect it anywhere, so you can use these power pins. And in the center there's a small black chip, and that is the brain of a nano. That is where you run your code, and that what we call as IC, integrated circuit. So now we are not going into each detail just yet. The next few slides we will break down each type of pins and parts, so you will really understand what each of them does. Let's talk about power pins on the Arduino Nano. These pins are super powerful and important because they help us power other components like sensors, LEDs, motors, and many other components. They are also how we get power into the nano board itself when we are not connecting any USB cable. First, we have VN pin. This is where you can connect a battery or an external power supply, something like 9-volt battery. It gives power into the board. Next is GND, which stands for the ground. You will always need a GND pin when you connect any component. It basically completes the electrical room, and without it nothing will work properly. So this pin is very important. Then we have 5V pin, 5 volt. This gives out 5 volt of power. A lot of components like sensors or other small modules use 5 volt to work. So if your sensor needs 5 volt, this is the pin you connect it to. There's also a 3-pin pin, that means 3.3 voltage pin. Some components like Bluetooth module needs a lower voltage, and this pin gives out 3.3 volt. It can connect 3.3 volt if you want to connect a device to 5V by mistake, you could damage it. Like if you have to connect it to 3.3 but you are giving more power by connecting it to the 5V, then you can damage your module. So always check the voltage your component needs. Finally, there's a reset pin. This can be used to restart your nano board from a circuit. It's like a pressing a little restart button without touching the actual button. So remember, V in is for power coming in. 5V and 3.3 are power for going out. And GND is your ground, and reset gives you a fresh start when needed. So now let's move to the digital pin on the Arduino Nano. These are the pins that help us to control things or read if something is on or off. Like if you want to turn on your fan, you just switch on or off the switch of the fan. They work in just 2 states, high or low. High means on and low means off. So on the Nano, you have digital pins number from D0 to D30. For example, if you want to turn on LED, you just want to do on and off with the code, you would connect it to one of these digital pins from D0 to D30. Then in your code, you can say something like, hey pin, can you please turn on or turn off? So some of the digital pins also have a little tilde symbol next to them, like pin number 3, 5, 6, 9, 10 and 11. These support PWM or pulse width modulation. Sounds fancy, right? But it just means you can control things like brightness of the LED or speed of the motor instead of just on and off. So you are basically modulating the signals. And one more important point is pin D0 and D1 are also used for communication between Arduino and your computer. So if you are uploading a code or using a serial monitor, avoid connecting anything to those pins, which means D0 or D1. So let's suppose if you are connecting a buzzer to D8. So you can use code to make sounds or alarms. So digital pins are like board voice. They can help it send commands out or listen for the simple signals. So these are input and output pins. So next are the analog pins on the Nano. These are a bit different from digital pins because instead of just on and off, analog pins can reach level or read level like brightness, temperature or pressure. Think of it like a dimmer switch instead of just light switch, or if you are using a regulator or to change the speed of the fan instead of just switching on and off the fan. So on Arduino Nano you have 6 analog pins from A0 to A5. Each one of them can take input from the sensors and send varying signals, different type of signals. For example, if you are using light sensor, it does not say light or no light. It tells you how much light, what is the intensity or the brightness of the light. That kind of signal needs an analog pin to understand. So if you connect a temperature sensor to A1, it can tell you the actual or exact temperature, not just hot or cold, right? So another cool thing, analog pins can sometimes also be used as a digital pin if needed. But actually we save them for the sensors that gives us detailed data. So to summarize, use analog pins when your sensor gives range values, and if it just tell on or off, go with the digital pins. Now let's understand something very important, the difference between digital pins and analog pins or Arduino Nano. So let's start with the digital pin. As I told you, these pins can only understand two things, on and off, also called 1 or 0, or high or low. That means high, on and 1 are same, low, off and 0 are same. Imagine a switch, it's either on or off. That's how digital pins behave. We use these pins when we want to control simple components like LED, buzzer, switches or a fan just to turn on and off. That's it. And on the other side we have analog pins. These are a bit smarter. They can read a range values from 0 to 1, 0 to 3. That means it can sense things like how bright a light or how warm the room. We use them with things like light sensor, temperature sensor, potentiometer, distance sensor and many more things. Here's the quick example. Let's say you are measuring a light. So if you are measuring a light, a digital sensor would say yes, there's a light, or no, it's a dark. But an analog sensor can say, yeah, it's kinda bright or it's kinda darker. So you can also see in the graph, digital signals jump. They are either high or low, nothing between them, like either 0 or 1, that's it. An analog signal moves smoothly. They can go up, down, anywhere in the between, right? So digital signals are direct up, goes if it is 1 for some time limit, or it goes down, that means instantly it goes off. but analog signal, it go with some time from 0 to 1 with different range. So in short, digital is like yes or no, or analog is more like dimmer or brighter or a scale. So both are important and we will use both of them when we start building. Now let's talk about this little red button you see here. This button is called a push button and it's super smart in a simple way. When you press a button, it sends digital signal to the Arduino. Digital means, as I told you, on and off, like flipping a switch. So when you press the button, it's like you are telling the Arduino ki, hey, something just happened. And Arduino listens carefully and says, okay, now I will do what I'm supposed to do, like turn on a light or make a sound. So this button helps Arduino know what you want to something or write something to happen. That's why we call it a digital input, because it's your way of giving command to the machine. Like if you want to turn on your laptop, how do you do that? By pressing the button, the power button, and your laptop gets turned on. So every time you push this little button, you are sending a message, and that message can make your project alive. So let's play a game. I'll give you 10 seconds to think whether this red push button is an input device or output device. I'm giving you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, that's it. Some of you might be saying input or output. So I'll tell you. Imagine you are pressing a button like this push button. So what is it? Like you are giving the instructions to the laptop. So what it is? Obviously, it's called an input device. Your push button is an input device. It means you are giving information to a computer or a machine. Easy, right? So now let's think about LED light. When you turn the light on and it's giving you the signal, like says, hey, I'm working. So that's called an output. That means the LED light is an output device because it gives us a data in the form of light. So it means the machine is giving information back to you. So what connects the input and output? That's where Arduino comes in. And Arduino is a tiny computer that can read what button is doing and decide what to do next. Like, should it turn on? Should it make sound? That's its job. Whose job? The Arduino's job. Look at the picture and you will see different kinds of input like gas sensor or a smoke detector, and output like a speaker or blinking LED, right? So remember, button is your input device. LED, because it gives output or data in a light form, it's an LED. It's an output device. And Arduino is a processor. Now on the next question. Buzzer, what is it? Output device or the input device? Think. Yeah, buzzer is an output device because it gives you a signal or data in a sound form. So let's write a code. Now let's talk about how we tell Arduino to do anything, any instructions. So these symbols you see here, which symbol? These Arduino logo. That's Arduino logo is for Arduino IDE. A software we can write a code for our project. It's kind of like a brain of a robot brain. That is where we give or type instructions. It compile it means it check the errors. Compile means It converts the high level language, that's a language we write in, to the low level language. Low level language means the language which computer understands, or the binary language. It checks the error, it compile it, means converting from high level to low level, and then upload. So let's look deeper in Arduino IDE. The software will actually being used to write or send code to our board. First, IDE stands for Integrated Development Environment. Sounds fancy, right? But really, it just means a place where you can type, check, or send the code. The code we write here is a sketch. It's written in a simpler version of a C++ programming language. But don't worry, we don't need to write a huge complicated thing. Arduino uses simple command that's a beginner friendly. Once you write the code, the compiler inside the IDE translator it into the language the Arduino understands. It converts it into the language that Arduino understands. As I told you, what is the language that Arduino understands is the binary language, like converting a simple English into machine language, or that the machines which speak or understand. So files we save here have extension is .ino. So whatever you say, let's suppose you are saving LED blinking, so you can write ledblink.ino. So the project might be called blink.ino, LED blink.ino, whatever you want. Now if you see, there are two main parts in every sketch or the code. First is the setup. This runs once when the Arduino starts. It only runs once when the Arduino starts. And next is the loop. It keeps running again and again like a loop in a circle. You also see something called camel case here. That's just a way of writing where you don't put spaces between the words, like a camel hump. First is the camel hump is something like this. So the format is also like that. The case, it's a camel case. If you are writing digital right, digital D will be the small and the W will be capital. So you will go over all this together step by step. So for now, just remember that Arduino IDE is where you write the instructions and Nano follows them. Hello, welcome. So today we are going to connect Arduino and breadboard first. Make sure the first pin of the Arduino should be at E30 and last pin should be at E16, and connect it and insert it. Once you are done here, bring an LED. It has two legs, longer and shorter one. Connect the longer one at 4J and shorter one at 6J. Longer one is positive, shorter one is negative. Then bring a resistor. Connect one leg of the resistor at 4I and another leg of the resistor at 4B. Now bring a jumper wire. Connect one jumper wire at 4A and another one at C21, and connect another jumper wire at I6 and another one at C19. Now your circuit is done. Upload your code, connect a wire, then upload your code and see it is blinking. So in this session, we connected one LED to the Arduino and saw how it's light up when we press the button, or how it blinks LED according to our code. That's right. So, but in the previous session, we have learned series and parallel. We learned how series and parallel work and how we connect them as a circuit with 3 LEDs. So now it's time to level up. So here your task, try connecting 2 or more LEDs to the Arduino. You can do it this like in a series connection where the LED shares the same path. You remember, right? We did it in a previous session. Or in a parallel connection, the path is not same. Each of them have their own path to the power. So you have to do it. Obviously, I'll show you how it works in the next slide, but I want you to give it a try